morning, fancy meet computers. How's everybody? How's everybody today? Today? You know what? I'm gonna check my all right. Whoop. There we go. Nope. My good mic is still ugh. Good. How am I? I am doing okay. Got a good night's sleep last night, which helped. You don't realize how precious something like a good night's sleep is until you have children, let me tell you. There we go. Let's see here. Slides. Does McMaster CompSci program have an electronics course? It's a decent question. Teaching MD3. Gotta get slides. There we go. All right. Bop. Good. So, let me see. Let's see. First question. Electronics courses in CompSci? Master Registrar. Bop. So, I'll kind of, no, this isn't what I want at all. Course calendar. I will take a look. Executive education. There we go. Undergraduate. Let's see. Select a calendar. This one. Yeah. Let's take a look. CompSci. This is going to take forever. Well, like actual electronic stuff where you would do actual like labs with electronics, I think that you would probably need to take a course from outside of the CompSci stream as an elective to be able to get that. That's what I'm going to say. I don't know how people operate on little sleep. It's, yeah, well, it's kind of like one of those things that it is what it is, Yeah, it's like, man, those first 2 weeks after you have a kid, like, my wife and I took it in shifts. But essentially, like, you would have, if you were lucky in the night, you'd be able to get a, like, 4-hour chunk. Like, the most you could continuously get, like, when Felix was just a real brand new newborn, the most you could get was, like, a 4-hour chunk of sleep continuously. Yeah, you might be able to get, like, one of those in and maybe, like, another 2 at some point, maybe. But yeah, it's kind of like being in a war zone. You never know when the air raid siren is going to go off. But babies, when they're very, very small, need to eat like every 2 hours. So because we staggered it, um, you know, we alternated, so both of us were hypothetically able to get like 4 hours in. But noise canceling cribs. um, well, see, the thing is about a baby crying is the baby is always correct. That's the that's the thing you have to come to realize very, very quickly when you become a new parent is the baby is always right, and you accommodate yourself to the baby um, until the baby can start taking instruction. At that point, you can start to train the baby um, to like not pull things off of shelves and stuff like that. Felix is at the he's at the stage where like he's beginning to understand a few words. Like he can't speak any yet, but he understands a few words. Like I'm pretty sure I taught him what no means the other day, but yeah, it's just repetition. But yeah, so anyway, little sleep, yes. How do you manage with very little sleep? You just kind of don't have a choice. You know? Yeah, baby trains you. That's the correct way to think about it. Actually, yeah, the more I think about the whole parenthood thing, the more I think that's very much the case. It's like nobody goes into parenthood having any clue what it's like to be a parent, you know? So like parents are also learning on the job, you know? But fortunately, you know, 400 million years of evolution has conspired to produce parents and children who have a tendency to not cause each other to perish. So there you go. Then they learn how to manipulate parents. Well, yeah, we're gonna have to nip that one in the bud, that's for sure. How old is my older kid? I only have the one at the moment. Felix is 7 months old, and he's the first. He's my firstborn son. So if Rumpelstiltskin were, if my wife had made a pact with Rumpelstiltskin that I wasn't aware of, he would be the one that had to go off to Fairyland. I'm pretty sure my wife didn't make any deals with Rumpelstiltskin. Anyway, we should probably talk about visualization. So I'm going to do this inside of the Jupyter environment, just because it's a little bit easier. It's a little bit easier, and making life a little bit easier is something that you got to learn how to do when you have small children. Put that quote in the next meme video. Yeah, where's Ryan? Let's see. Jupyter Notebook. Make a new one. Python 3. We shall call it Graphs and Things. There we go. Bop. So let's talk about visualization. So, as I stated previously, what we're actually talking about when we're talking about visualization in this sense, we're not talking about, advanced 3D rendering. We're not talking about clipping planes. We're not talking about ray tracing or programming shaders. What we're talking about is graphing in the statistical sense. If you want to learn about all of that kind of stuff that I just listed, I believe there are fourth-year courses on parallel computation that may be of interest to you. Used to be taught by a good friend of mine. Then he graduated. So there are many different libraries for plotting in Python. Pylab, pyplot, and pandas. People often bang on about pandas to me, but you know. So we'll be using the pyplot interface in this course, but other interfaces can be more powerful. It depends on what you do with it. The advantage of pyplot is that the syntax is basic, and it also builds on the object-oriented stuff that we pardon me, the object-oriented stuff that we've been learning. You may have noticed, once we covered objects, right, basically the rest of this course up to this point has been different objects or different classes for different things. Like, we're now learning the applications of classes. So it's good to sort of tie this back to the classes work that we were doing. So, Matplotlib is a optional Python set of packages for plotting. If you downloaded the Anaconda distribution, you already have it. If you do your work on JHub 2, you can also get access to it that way. If you want to install it on your local computer, you can use pip3 python or sudo install from the command line. If you did not install Python from the command line, it is very likely that you installed it via the Anaconda distribution. So if you don't want to or can't be bothered learning how to install it from the command line, I recommend Anaconda. So, we can get plots from Matplotlib to show up directly in a Jupyter notebook using the Jupyter Magic command matplotlib inline, which displays non-interactive images in the notebook. So, let's set that up real quick. There we go. So, that graph is wrong. Ugh. Oh well. We'll see what the graph is supposed to look like. So, in order to graph, import matplotlib.pyplot as, I'm just going to say P. We then set up some arrays of x values and y values. So let's say x is equal to 1, 2, 3, 4, 5. Y is equal to 8, 4, 7, 2, 9. There we go. Then pyplot, or actually it's p dot plot x, comma, y. P dot show. There we go. So this topic feels like a jump in a different direction. Yes, it will feel like that, absolutely. To be completely honest with you, like for those of us who don't have MATLAB installed on their computers, Python is a very good, quick and dirty way to be able to perform a lot of the graphing functions that you would traditionally use MATLAB for. So, let me just run this. There you go. So, in order to show you what the purpose of this line here is, I'll just take it out and run it again, and hopefully it'll change. Nope, it doesn't change. All right, so I guess it's enabled by default. So the line matplotlib inline basically sets a optional parameter inside of the Python interpreter that's running underneath the Jupyter instance, and it tells it to to do the matplotlib as inline in the Jupyter Notebook context. So it's just like that's what it means by a magic method. It's not like it's not a feature of Python the language. It's a feature of Jupyter Notebooks. All right. But the reason I'm doing this in a Jupyter Notebook and not doing it, for example, in command line like I usually do, is command line can't display images, right? It can only display text. So that's why I'm doing this in Jupyter. But yeah, apparently that option is already set by default. Or it's also possible that I only needed it once and now it's just set. Like, for example, if I save this and close it, halt, there we go. Oh, that just closed it completely. All right. Yes. If I try here again. Let's see if this works. Yeah, it still works. Strange. Anyway. So anyway, I guess it doesn't really matter. At least, maybe it mattered in old versions. So anyway, so that's how you... get out of here, you. So that's how you would plot, like, a scatter plot. So the thing to notice here is that, you know, 1, 8, that's a coordinate, 1, 8. Like, it's plotting these as points and as a line graph. If I were to, for example, reverse the y, you see it reverses that. If I were to reverse x, it puts it back the other way. So, there we go. So this is like a line graph, right? It's not a scatter plot, it's a line graph. Technically speaking, the only difference between the scatter plot and the line graph is that the points on a line graph have lines drawn between them. So you can easily, like, coerce this into being a scatter plot, but yeah. Why the numbers on the x-axis are floats? I don't know. I'm entering integers. I should get integers out, right? I don't know. Would you be able to do pyplot reverse the x in here? Yeah. Yeah, there you go. It just reverses the x axis, right? Bam. So anyway, so that's how you plot stuff. Get over there. There we go. So this is fine for plotting, you know, point information. What if we want to plot a function, right? So let's rather than just sort of specifying x values here, I'll do this in a new cell. How's that? Rather than just sort of manually specifying these guys, let's specify a range from -100 to 100. And let's say, and this is going to be, for some of you, this might be the first time you've seen a list comprehension. Can I use x prime? No, I can't use x prime. Prime. Oh, I've got insert. Oh, I hate insert. For x prime in x. There we go. So, executing this, you can see we got the graph that was over here. So, essentially what this is doing, range is, of course, generating a long list that contains every number between -100 and 100. What is the shortcut to fix insert? It's the insert button on your keyboard. I accidentally hit it with my finger because I have fat thumbs. So what we're doing here with y, this is a list comprehension, right? So for each value in the specified data structure, in this case x, we designate a temporary variable name x prime in the same way that you do during a regular for loop, and we say this, the result that is stored in this array is that temporary value raised to the power of 2. Merci beaucoup. De rien. Yeah, so this is a list comprehension. If I were to print out the list, if I were to print x, print y, this is like x is the range, right? And then y is everything in that range raised to the power of 2. You can see the 0 is right there, and that's all powers. So there you go. So this is fine. This is pretty good. However, one might be saying the scale is a little, big, isn't it? What if we only were concerned about the range from, say, -5 to 5? What happens if we tighten it up? Let me just make it all pretty like. Now, brown cow. Now that's an interesting thing, right? So notice this curve here is as smooth as a baby's bottom. This curve has started to introduce polygon jank. So, what is the origin of said jank? Well, it's very simple. The closer you get to 0 and under this configuration, the fewer data points you have to work with, which means that the data points that you do have sort of get connected. Like every point is connected by straight lines, even these ones. It's just in this case, the points are so close together that it gives the illusion of being a continuous curve. Whereas this one, you lose that illusion because you don't have enough data points. So how would we go about this then? If we want to, what we essentially want to do is we want to be able to interpolate points that are less than whole integers, right? So what would happen if we just sort of popped 0.01 or 0.01 as the last parameter here, the jump by parameter? What do we get? Ha! We get a type error. Float object cannot be interpreted as integer. So essentially what we need to do is we need to come up with a new solution. We're going to define a custom function called fRange. Floating point range. From x to y by skip. So, start with a list while x is less than y. L dot append x plus equals skip. There we go. Return L. So if we were to then print our fRange, invalid syntax, of course. There we go. So you can see, first of all, you can see that, like, we've got our floating point error showing up very nicely. So the problem with this type of algorithm is like if you're performing like looped additions, then you're gonna accumulate the floating point error, which just looks horrible by the end. But shouldn't you skip a default value of 1? Oh, yeah, I should give a default value of 1. There we go. Thank you. Looks like lightning. Yeah. Yeah, it kind of does, doesn't it? We got a really interesting value for 0. But, so, the trick, of course, here, though, although it doesn't show up very nicely when you print out the numbers, all of these floating point errors are sufficiently small that when you actually graph them, they don't really show up. So you get the smooth curve that you had from before, but now we're only on a range from -3 to 3. So everybody's happy. Cool. Yup. Yup. I just did those slides. Good. So, yeah. So you don't have to just graph parabolas as, as you might expect. If we import from the math library, import math, we can do some more interesting ones. So, for example, math.sinx. I'm gonna stop printing that. Getting an error. Must be a real number, not list. Oh, right. Prime. There we go. So if you wanted to print like a sine wave, right? Can you add by 1/8 or any negative power of 2 to minimize float errors? Ah, there's, yeah, okay. So, so my solution to this probably would be something like, figure out what the precision is of skip. So, something like precision is 0. Skip fake equals 1 while skip fake is greater than skip. Skip fake divide equals 10. Precision equals 1. And I'm pretty sure, like, Python round, you can set the precision. Yeah. Number of digits to round to. Yeah, I'm pretty sure. Yeah, I think this will work. Precision 1. So x plus equals skip, and math dot, it might just be round. Round x to the number, the precision, that's supposed to be a plus equals. The amount of precision that was originally in the input parameter. And if I have managed to not catch myself in an infinite loop, then I think I should be able to get away with it. Not quite, eh? So, print skip skip fake and print precision. see what we got. So precision, it says 1. So maybe I need to have it at 1 already. Or maybe I just need to... There we go. I think you have to round before... Ah! Yes! Thank you. What we should actually do is put that there. Maybe. Maybe this will work. Yeah! There we go. Bully-o. So this probably was unnecessary. I could have just picked something that was above the floating point error limit, you know? But, yeah. There you go. What if you multiply instead of repeating addition? Multiply tends to make it worse, actually. But you would always be starting from the same point, so you would... you wouldn't be accumulating the error over time, but multiplication tends, like the baseline error tends to be worse. Okay, you're going to hate me for asking this, but I have trouble doing things without it. Okay. So, can you use list comp to quickly make a list of floating point numbers as well? Oh yeah, like list comprehensions can be used to produce any type of list that you would like. What is this type of thing used for? Like, what do you mean? Like graphing, or like the being able to generate a range of floating point numbers equally spaced? Graphing. What is graphing used for? Well, I found it useful sometimes when I'm putting together lecture slides. If you have data, then it's useful to graph it because it's a much easier way to pick out important features of the data. Parabolas, like, well, we don't really, like, there's no purpose in parabolas specifically, right? It's like, it's an example it's just an example, right? It's an example of some data that I can generate quickly on the fly to give you the techniques for graphing. So if I were to do 1 over x prime, yeah, we'll see if I get a floating point error. I do. Or a zero division error. Let's see. +1. I'm missing closing parentheses. There we go. Oh yeah, I suppose I would have to, like... There we go. I tricked it. So, yeah, that's just, you know, it's a way of displaying mathematical functions in a way that makes sense to humans. So, let's talk about the other types of graphs that you can do now. So, going back to a previous example, so plot is like your default line graph, but if you replace that with scatter, scatter unsupported operator. Oh, I've got a friggin' extra character in there. There we go. So if you wanted to do a scatter plot instead of a line graph, then you just select the plot as scatter rather than plot as line graph there. Does it really make sense, though? It is what it is. Um, yeah, like, asking me to justify why we need to graph things is like asking me to justify why we need math in the first place. It's like, okay, I'll try. So, graphing is parametric geometry, right? When you're graphing, what you're actually doing is you're manipulating geometry in concordance with data that you have acquired through some other means. Now, this data, you can acquire it in like so many different ways this data can come, right? Like if you're in a biology program and like I read one time that they use these little worms and how fast they swim to determine like motivation under different chemical environments. So like how fast worms swim depending on the concentration of some, some chemical in their environment. That would be something you would graph. You would graph worm speed versus concentration of chemical, right? And that would be useful to a scientist because they could look at it and say, oh, I can see very easily from this data that as I add benzene to the environment, the worm swiftly slows down and dies, And this type of information is useful to scientists. So, essentially, there are other pieces of software which you can get to do this type of work, for sure. Some of the earliest applications of computing, like basically as soon as computers had monitors, people were trying to graph data on them. So, to some degree, this is a long and storied tradition of being able to graph data, especially considering how much data we have floating around these days, Being able to make sense of data is one of the primary jobs of the scientist. That being said, I think a lot of the data, quote-unquote, that's floating around these days is like, in string format rather than necessarily numeric format, but then again, I could be wrong about that. But yeah, it's like, if you hook it up to a proper programming language, you could do something like, graph up to, graph the first three, pause like half a millisecond, pause for like 10 milliseconds, graph another one, pause for 10 milliseconds, graph another one, pause for 10 milliseconds, have OBS recording it in the background, and boom, you have an animation of a graph being graphed. Right? You can do that sort of thing if it's in a general programming environment. I guess data science and computer science overlap. Well, yeah, data science is a subcategory, sub-branch of computer science. Like, computers work with data. That's what they do, But yeah, so, can I do that right now? Well, let's see. Maybe I can. Yeah, sure. Let's do it on this one because it's simpler. Might be difficult. We'll see. I don't know if it'll work inside of Jupyter, but Python sleep function. Does Python have a sleep function, first of all? Time.sleep. Import time.sleep. Okay. So that should work. Import time. Python now has time. So let's say, int, or I is equal to 0, while I is less than the length of y. Do some stuff and increment I. P dot plot slice from the beginning to I. Do the same with x. Or no, don't do the same with x. Hopefully that'll set the range. Or maybe it won't. We'll see. We'll see what this does. Oh, it's just creating a bunch of them rather than deleting them. But you can see that, like, as time goes on, if I just hold the scroll bar down, if I force the scroll bar down, you can see it's actually animating, right? Which is kind of cool. And I know, like, I realize that I should technically be deleting these, but that was cool, right? Let's do it again, just for fun. Obviously, the more interesting this function is, the more interesting the animation is. And this isn't really an animation, but you can kind of get it in a kind of a rotoscopy kind of way that this is animating. There, that's pretty good. There, see? Animation. Ta-da! So let's go through some of the different types very quickly. So obviously, it's stop motion. It is stop motion. So generally speaking, like, we don't teach the sleep function because there's no real reason for it aside from animating, like, text or images or stuff, which is like, the sleep function is to animation as a subject, as a discipline, as, like, hitting something with a stick is like using the sleep function to animate is to animation as hitting some stones with a stick is to trying to break through the Great Wall of China. You know, like, animation becomes very, very, very complicated very quickly, but, you know, you can, from a sort of a fundamentals perspective, all that animation ever is a sequence of slightly changing images which give the illusion of movement, right? But should have taken geomatics. Yeah. Yeah. So anyway, so you can load data from a CSV file, right? Like, CSV files contain data that it's like the plain text spreadsheet format. So if you have data in a CSV file, you can do one of two things. You can either import it to a proper spreadsheet program, like, what's that one that Microsoft makes? Or you can load that CSV data directly into a Python program, and you can, you know, build up your X and Y values from the data in the CSV file and then plot them. And, of course, you can throw in that little animation thing that we just learned how to do. What even is geomatics? I don't know. Geological mathematics? Geometry? Geologists must be mad that the word geometry was already taken, hey? So, if it's got a header, obviously you can do it as a dictionary. Geography plus CS. Oh, geography. Geography and geology are two different things. It's those guys who do land surveying. So, there are various options that you can set. So if you call pyplot.title, you can set the title of the plot. So I'll do it on this this guy. Why not? So p.title some data. You can see it puts some data as a title in there. You've also got x and y labels. You can set the bounds of the you can set the axis bounds, you know. It goes x lower, x upper, y lower, y upper. You can set a legend. So data pyplot.legend I am legend. There you go. And you can also like turn the grid lines on. There are tons and tons of options. This is just a small handful of the most common ones that you might see. Grid is true. There you go. You can have a grid. Ta-da! Customizing plots. I kind of already did this, but yeah. So type error is possible if the data isn't numbers. It depends. You can pick a different type of plot though. Like for example, if you were to look at bar charts, the there are certain types of charts like bar charts where you can mix string data in, for example. So it's like you know. How do we match the legend with specific sets of data? Good question. Let's just do that quickly. So let's say we had y and y2. y2 is going to be 5, 4, 3, 2, 6. Sure. Then you would plot y, y2. You would have I am legend, I am error. I am not plotting that correctly. There we go. All right. So when you do that, you have to call separate. You have to call separately to scatter it. You have to put the two data sets in with different calls. But yeah, so you just, you know, add another string to the list of strings that constitutes the legend, and there you go. Incidentally, I'm pretty sure you can just... Oop, that's... It's not supposed to be all caps. Plot. There we go. Yeah. So you can, as a matter of fact, mix scatter plots and like line plots in the same graph. That's totally acceptable. But yeah. Let's see here. So I'll do an example of a bar chart very quickly. So let's say x is equal to soup, fruit, and spark plugs. And our data is 80, 47, and 92. These will be the approval ratings. P dot bar xy. Pretty sure we should get something. Yeah, there you go. So you can use like string data to indicate the categories if you're doing the right type of plot, right? This is actually really interesting. Wow. Who doesn't like soup? Like, honestly. I mean, as long as it's good soup. You can have terrible soup, but just like you can have any terrible food. I think that soup, like, starts off at like a 60%, and a good soup goes up from there. I'm a big soup guy. Basically, as long as as soon as I figured out that you can like save your old like chicken bones in the freezer and then make them into soup later, I was addicted to soup. Do we have any assignments on the graphing stuff? No, this is primarily informational. It's very difficult to like actually mark this with the autograder, so this is primarily for your interest and possibly for your use at a later point in time. Now, so the we're not doing anything that MATLAB can't do, right? But, you know, MATLAB is expensive and Python is free, especially when you're outside of the university setting. So, you know, MATLAB requires expensive and continuous licenses, but Matplotlib is absolutely free, so you can just use it. You know, even if you're not currently attending university. Can you do all this stuff in Matplot itself? Is it easier to do it in Python instead? So, Matplot, by Matplot, do you mean MATLAB? Time to use this graphing stuff in Calc. Yes! Yes! So, basically every computer you've ever sat at is a graphing calculator. Octave is crying right now. Octave is not very usable in my opinion. I've tried using Octave in the past, but I just haven't been able to figure it out, you know? Now listen, Jason. You may be, you know, you may be content with your piratical, immoral ways, but some of us have to at least give the appearance of never, ever, ever, ever emulating Mother 3 on a GBA emulator because they never released it in the West. Some of us never, never would do that sort of thing. Emulation is a crime, and you're a criminal if you suggest it. Yeah. Anyway, that's class for today. We actually don't have that much left to cover in terms of graphs. We just have to go through a few different types of graphs, and then we'll be on to talking about databases, which is something we actually do test on. So, any questions? I'm really pleased to see that this class has maintained like 50%, or not 50%, 50 people in the class by the end of class. That's really good. The class has 240 odd, we'll round up to 250, so like 20% of the people coming to class, that's amazing. So pleased. A lot of my other classes are down to 10%. Sampletweets.json can't be read for assignment 9. Talk to Mark. Or David. Actually, Mark's busy. Talk to David about it. End of class, gang. Yeah. It's only because you teach this class. Yeah, well, I teach the other classes, too, that I teach, right? So, I'm just saying that you guys are awesome, and I want to continue to teach you guys next semester with 1xc3. You're cool beans. Yeah, it's like I kind of get why the third years aren't showing up, because the third years are the ones in particular that are the most problem, because like what I'm teaching them is like high mathematics essentially, and like they have been just destroyed this semester with all of their courses. And I've tried not to destroy them, which is, you know, nice of me. I'm not going to be the straw that breaks the camel's back, I hope. But it also means that, you know, my course isn't the course that has the constant, like, my course isn't the one that's constantly beating them over the head saying, you have to study this, you have to study this. So, you know, they don't come to class. Yeah. I think the attendance in the, second year Tron class is still pretty good. Yeah, it's really just the third year's class where people have stopped coming to the lectures. And it's not even that they've, like, stopped coming to the lectures at, like, concurrently either, because, like, I looked at the, like, the viewer percentage, and, like, not every unique view does not, like, every view of the video does not mean one student watched the lecture, right? Because people will start and stop the lectures, and that counts as another view, I believe. So right now, the number of views I'm getting is like 60 people, or 60 views, which means that the actual number of people watching the lectures probably hovering around a third of the class, I'd say. But, yeah. Always gotta like the lectures, too, though. Yeah. One of the assignments should be graphing the correlation between attending class and high grades. I agree. That's a good one. I like that. Is this tendency the same for in-person classes? I don't, like, like, it normally is pretty bad. Not gonna lie. In an in-person class, normally, I'd say, for a class of, like, 200 students, towards, like, say the last week of class where it's the worst, right? Not the review session, but, like, the last class before the review session. I'd say you probably get, between 20 and 40 people showing up. But yeah, this is, like, it's kind of hilarious, actually. Let me see. I think I can just show you the statistics. I think I'm allowed to. Like, I'll just show you the viewership numbers if you're interested. But it's like, generally speaking, it's an exponential decay. Like, the number of students in class over the course of a semester is an exponential decay. So let me see here. Analytics. So, week on week, it doesn't look that bad. But if I were to increase that, so you can see how, like, the beginning of September, I peaked. So Tuesday's always the big views day because I have 3 classes on Tuesday, right? So it's like, start of the semester, like, I have 1,000 views, right? Next week, like week 2, it's down to 735, 659, 562. Then the Tuesday's down to 366, you know. Oh, so after reading week, it's kind of bumps up a little bit again because people have been able to get a breather, but then it's like, I think I had a midterm this week. But yeah, it kind of steadily declines over time. Although last week wasn't too bad. It seems to have stabilized, but you can see that, like, the difference between the troughs, like the number of people watching on Saturday and Sunday, increases as the semester goes on too, but not as much as this declines, right? So it's like the pits raise a little bit, but the peaks coming down, like, just means that there's just fewer views overall. Soon turns out to be a flat line. Yeah. Well, I mean, you know, it is a flat line in August. Well, actually, I'm pretty impressed with, like, I'm getting, like, maybe, like, 25 views on average per day without actually teaching any classes. That's not bad. How did I design my icon? Oh, I have a, um, well, on my other laptop. I haven't, like, imported my game dev stuff. I just did it in, like, a little simple paint program that's designed for sprite work called Asprite. 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 But this is a really good one. If you like, if it's like pixel, if you like the pixels, but yeah, it's just a pixel editor. Incidentally, the never ever ever rotate pixels. Never rotate pixels. There's no lossless rotation algorithm for pixels. So anytime you rotate pixels, you're gonna lose it, and you always have to reconstruct it. So, if you have to rotate pixels, keep it to like 90 degrees. Yeah. Yeah, my friggin' pinball game used a lot of I did like all the sprite work for my pinball game myself. Now, like this, the way they're doing this makes it look like it's a game development um, sort of platform, but it isn't. It's just doing sprite animations. Commission someone to draw something fun. Meh. I used to make them in an art program and throw them into Google Slides to see the animations. You need to upgrade your software. Yeah. Anyway, so that's I guess that's everything. Take her easy, folks, and I'll be seeing you on Friday. Take her easy.